This is the first of the index laws. So this is the index law that states when multiplying algebraic terms with the same base. Okay, that's very important. Okay, it must be the same base. We add the indices. Okay, so first of all, I guess what do we mean by the base? What's the base of a number that's expressed in this form? This is the base here. Okay, so the base would be, for example, the x's. Okay, so that'd be the two bases. As long as they're the same, we can apply this index law number 1. Okay, so for example, x squared multiplied by x cubed is equal to x to the 5. We add the indices, so 2 plus 3, 5, and this will be our simplified expression. So the question is, why is this so? So let's break this down. X squared times x cubed. An index really is repeated multiplication. Okay, so it's just a shorthand way of writing a multiplication that multiplies the same term over and over again. So x squared is really just x times x. X cubed is x times x times x. And they're being multiplied together. So I've just put them in brackets just so, just for clarity, you can see what I'm doing here. But because everything is just being multiplied together, the brackets actually don't matter. So we're going to remove the brackets because it does not change the answer, or it doesn't change what the final answer is going to be. So then we have x times x times x times x times x. There's 5 of them. So we could write it as x to the power of 5. Now this would work with anything. I mean, I could have, for example, if I was to make that say, x to the 4. That's just the same as adding on another 4 x's. Okay, and we would have x to the 9. Let's have a look at some other examples. Okay, so let's simplify the following expressions, leaving your answer in index form. Okay, so 2 cubed times 2 to the 4. Now, of course, you can enter in on your calculator directly and get an answer. Okay, an answer that doesn't involve indices. So, in fact, how would you do that? 2 to the power of 3. Okay, use a little bit of power button there. Okay, times 2 to the power of 4. Okay, press equals, and we get 128. But we're going to leave this answer in index form. Okay. First of all, are the bases the same? Yes, they are. As long as the bases are identical, we can add the indices together. So that's going to be 2 to the power of 7. Okay, what about part B? Okay, a squared times a to the 4 times a to the 6. Okay, now we saw that before when we were looking at the pronumeral x, and we added another one, x to the power of 4. You just add the indices. Again, as long as the bases are the same, you could have 1,000 of these. It doesn't matter. You just add the indices. There's 2 a's there, 4 a's there, 6 a's there. 2 plus 4 plus 6 is 12. So it's going to be a to the power of 12. Okay, what about this one here, part C? We've got a squared times b squared times a times c. Not all the bases are the same this time. And also, we have an a without an index. So a pronumeral that doesn't have an index, it's assumed that the index is 1. Same thing with the c here. We assume that the index is a 1. Now we need to look at bases that are identical or like bases. So we have an a squared here, we have an a to the 1 here. Because the bases are the same for this a and this a there, we can just add the indices. So that's going to be a cubed. Now we have a b squared that's on its own. There's no other b anywhere else. So we're going to write it just as b squared. We don't have to show the multiplication symbol, okay, in algebra. And lastly, we just have a c on its own. Well, again, there's no like bases. So we just write it as a cubed, b squared, and c. Okay, part D. 4y times 5y squared. The y is on its own. That doesn't have an index. Actually, doesn't. When I say it's on its own, its index is not shown. So we assume it to be an index of 1. It is being multiplied by the 4. So the y, while it's on its own, it's not being there's no other y's multiplying it. Okay, so it's just the y by itself with a 4 next to it, basically multiplying that. The y squared, that's y times y. So there's 2 of those y's there. Then you have 4 times 5, they're the ordinary numbers. Okay, so the first thing we do is multiply the ordinary numbers together. So 4 times 5 is 20. Then you have like bases. Again, as long as the pronumeral is the same, that's all we care about. Okay, so y and y, that's fine. They're identical, we can add the indices. So 1 plus 2 is 3. So we write it as 20 y cubed. Okay, part E, again, do it the same way. There's no difference. Just because there's a negative sign here, it makes no difference to the process or the method that we use, or to the theory, in fact. Let's multiply the numbers first. So we have 3 times negative 8. Okay, that's equal to negative 24. Okay, the bracket here just means that we're dealing with a negative number. That's all that these brackets mean. Okay, it's not a minus sign, it's a negative symbol. Now let's look at the bases that are identical. We have a g squared multiplied by g squared. 2 plus 2 is 4. G to the power of 4. Then we have a h and a h. Okay, remember, when a pronumeral is on its own with no index shown, okay, so when I say it's on its own, is it's a h by itself, there's no other h's multiplying it. We assume that it's an index of 1. H to the 1, there is another h somewhere else. Actually, there's in fact 3 of these h's being multiplied together. H to the 1 times h to the 3 is also h to the 4, same index. Okay, different bases, but the same index there, 4 and 4. And lastly, okay, this one's a sort of a question in reverse. Okay, so what we're going to do, come up with an expression that simplifies to 18 a squared b to the 5. So there's unlimited answers. You can come up with your own, you can come up with 2 if you like. I'm going to come up with maybe a couple here. 18, well, think of 2 numbers that multiply to give you 18. I know, 6 and 3. Okay, so might write 6 and 3 that way. And 2 bases that when you multiply them, or two terms with the same base that multiply to give you a squared. Well, I can put an a here and an a there maybe. And a b to the 5. I don't know, b and b to the power of 4. B and b to the power of 4. Multiply those together and I'll get 18a squared b to the 5. Now can you think of another one? Okay, I'll think of something a little bit different here. Why don't we use negative numbers? So maybe negative 9a squared b squared multiplied by negative 2. Okay, I already have an a squared here, so there's not going to be any a terms here. I've got a b squared here, but I want b to the 5, so I'm going to have to add another b cubed here. Okay, I'll just put brackets around that to show that it's a negative number. 2 negatives, when you multiply them, you get a positive. A squared is on its own, it's not multiplying anything else, you got an a squared there. Then you've got b squared multiplied by b cubed, you get b to the 5. So in fact, both of these are fine. See if you can come up with some other ones.